Hi dear students, how are you? I hope you're fine. Today we're going to talk about a new lesson. It's about sector area and arc length. So today we're going to find the area of the sectors and we're going to find the arc length together. So let's start. Okay guys, so I have here a new thing which is very easy indeed. I'm talking about here the area of a sector. So the area of a sector is just a fraction of the circle, part of the circle containing this sector. Very easy. So to find the area of the sector whose central angle measures m, so multiply the area of the circle by measure of this angle over 360. What are you talking about? It's very easy, don't panic. We have here the sector of a circle. I have here, what's the sector of the circle here in this diagram? It's ACB. Can you see this? It's ACB. So the sector of a circle is a region or a part of or this figure that bounded by two radii. So it has here the two radii, one radius and another radius. Okay guys, and what else? And their intercepted arc. So this is its arc. So I have here what? The arc AB. So you got here what? I have here, this is called the sector ACB. I want to know the area of the sector. What should I do? The area of the circle, as we know, pi r squared. So I'm going to say pi r squared of the whole circle, no, of just this sector. So take here this measure of angle over the total 360 of what? The total measure of angles of a circle. So this is much easier, I know. Let's have here an example. Find the area of each sector, give answers in terms of pi. So I'm not going to calculate pi, thank God, and round it to the nearest hundredth. Very easy. So he asks me for HGJ, sector HGJ. What's my rule here? Use the formula for area of sector, pi r squared times here the measure of angle over 360. Substitute, guys. Substitutes here the r, the radius here, and pi will be the same. Radius will be 12 power 2, and the measure of angle here 131 pi r, which is 12. The radius is here fixed by 131 over 360. It's very easy, right? But remember the rule very well. This is the question. So I'm going to simplify by here, remember, I'm going to answer in terms of pi. So pi be the same, 12 power 2, guys, times what? Times 131 over 360. By using the calculators, we're going to find the answer. Remember to round it to the nearest hundredth. Let's have another kind of questions. I have here a windshield wiper. Wiper blade is 18 inches long. To the nearest square inch, what's the area covered by the blade as it rotates? Okay, rotates through an angle of 122. So he asks me about what? About the area of the area covered by the blade as it rotates through the angle 122. So I'm going to use what? I'm going to use this formula of the area of the sector. So pi r squared, because here, how did you know this is a circle? It rotates, so I'm going to have a circle. Okay guys, I have here the windshield wiper blade is 18 inches long. So what do you think, guys? Here radius here is what? It's 18 to the nearest square. Okay, what's the area now? So I'm going to substitute here the given information, 18 for the radius and 122 is for the angle given over 360. Then the answer will be 345. Let's have another thing here. We got a segment of a circle. What's a segment of a circle? A region bounded by an arc and its chord. Let's see it here. It will be better for us. We have here the area of the segment is what? Remember, I have here area of the segment it's equal to the area of the sector. It's equal to the area of the sector minus what? Minus the area of the triangle. So again, area of the segment equals what? Can you see this? This is the area of the segment. It's equal to the area of the whole sector minus the area of the triangle, of this triangle. Okay, we can't understand anything now. So let's have an example to see what we are talking about. Okay guys, focus with me. Find the area of the segment LMN. LNM. LNM. Okay guys, he asks us to find the area of this segment to the nearest hundredth. So I'm going to use the formula of what? Of the area of the sector first of all. So I'm going to get the area of the sector of LNM, this sector. Okay guys, this one. So how can I get the area of the sector? I'm going to multiply the radius by r squared times what? Times 120 over 360 first of all. And then you got it. It will be 27 pi centimeters squared. We got here second step. Okay guys, remember L and M here. And I have here to put it. Here as if I'm taking this and put it here. Find the area of LNM, triangle LNM. Okay, and I don't know what's the area of the triangle, half base times height. So I'm going to draw an altitude because you got here an acute triangle. So draw an altitude or height here as you see. So after that, we got here that LM is what? LM here is 9. Okay, by using here the right angle triangle rules. Okay, so you got here LM is what? 9 square root 3 and the height 4.5. Okay guys, so half base times height here equals what? I got here half of the base, which is LM, that I just calculated, and I will give you I will give you this as a given. Okay, and the height too, I will give it to you as a given. Okay, half base times height here, then simplify. So you got here the area of LNM. Step 3, I'm going to get the area of the LNM sector minus the area of that triangle here. So you got it here by using the calculator. In the same way that the area of a sector is a fraction of the area of a circle, the length of an arc is a fraction of the circumference of the circle. So let's see this by this diagram. As you see, I have here the arc length. The arc length, guys, as you see, the red arc length here is the distance between the distance along an arc measured in linear units. So we have here the length equal what? 2 pi r. Okay, the last one 2 pi r squared. This 2 pi r. So it's very easy to, yes, it's very easy to memorize, times measure of angle over 360. So let's have an example. Find each arc length and give answers in terms of pi and round it to the nearest hundredth. So he asks us for FG arc. So how can I get FG arc now? Remember, pi r times measure of angle over 360. Use the formula. So 2 pi r, remember 2 pi r here for the length. Okay, let's substitute. I have here the radius. Okay, sorry. I have here the radius, which is what? The radius here, which is 8. And I will write the formula and substitute in the formula here. So I got the answer, and he asked me in the terms of pi. I'm not going to use pi. Okay, this is a question for you. Okay, please do this as homework. See you guys at school, and if you have any questions, you can send me on the new SCL. Please do this as homework, and I will send in steps. Please do this as homework in steps. And also this number 3 and 4, do it as also homework and send it to me on the new SCL program. Thank you for listening. Bye bye, my dear students.